All right, we are going to re-record the first half of this lesson because it did not get recorded in class, but I'm just going to go over the first half for those of you who weren't here on this day. So in the beginning of this lesson, we are learning about reflections. So when we are reflecting a transformation or a function, we are flipping it over either the y-axis, so it's backwards, or over the x-axis so that it is upside down. So when I take my y and I replace it with negative y, what does that do to my equation? So if I have a function here, y equals the function x squared plus 2. X squared we know is a parabola. Plus 2 means its vertex has been shifted up 2. So 1, 2, here is the vertex, and then 1, 1, 2, 4. So this is what my original y looks like. Then I'm going to take my y and I'm going to replace it with negative y. If I have negative y equals x squared plus 2, to have just y equals by itself, I need to divide everything by negative 1, and I end up with an equation that looks like this. This is the transformed function. So where is my x-axis? My x-axis is right here. My base function, my original function, was this parabola looking like this, as we see on the left. So once it's negative, it's being reflected, so we're flipping it upside down. So now I have an upside down parabola shifted down 2. So down 2 means the vertex is here, and we end up with a parabola going down. A mirror reflection, and we call this a reflection. I think I spelled that wrong. Miss Gordon, not very good at spelling. Reflection. Hashtag mathlete. Over the x-axis or upside down. So we are replacing y with negative y, and that means the signs are going to change on all the terms on the right side of the equation. Alternatively, if I want to flip it over the y-axis, so my vertical line, then I'm flipping it backwards like a mirror. And in order to do this, I take my x and I replace it with negative x. So here is my base function. This is a line, slope positive 2, y-intercept of positive 2. So y-intercept of positive 2, positive slope up 2 over 1, up 2 over 1. And then I'm going to do a couple of points backwards just so we can see what that line looks like. So that is my base function. In order to transform it, I'm replacing x with negative x. So that means I'm taking my original function and only replacing the x with negative x. Well, if I simplify this or expand the bracket, I end up with this equation here. Now I have a line with a negative slope and a positive 2 intercept, positive 2 intercept. And now I'm going down 2 over 1, down 2 over 1, down 2 over 1, and then backwards as well. Here is my new line. Here is the y-axis. You can see that line number 1 is has been reflected backward over the y-axis. So this is a reflection over y-axis. Okay, so when we are going backwards, we are replacing x with negative x. When we are flipping things upside down, we are taking our y and replacing it with negative y. And on the next page, we're going to do some examples of specific equations so that you can kind of see the difference in what it looks like original compared to the other reflections. So here we are putting the negative on the outside, meaning y goes to negative y. So this is my upside down. And here we are replacing x with negative x because the negative is on the inside. So x, replace it with negative x. So this one is going backward. Backward, upside down. Forgot the last word there. Okay, so let's see what that looks like. Here is my original function. If I want to flip it upside down, I'm replacing y with negative y, which means in order to get that negative to the other side, I have to divide everything by a -1. Or another way to look at it is saying, I'm going to put a negative on the outside of my function. So my function is f of x minus 1. I could even simplify this and or expand the brackets to say negative 5x plus 1. That would be all right as well. Ooh, you know what? I'm going to keep this side red. Negative 5x plus 1, since I started with the red pen. Okay, now if I want to do the reflection in the x, then I'm going to say 5 bracket negative x. I'm only putting the negative by the x minus 1. All right, so simplified or expanded, this would be negative 5x minus 1. And notice the differences. When we reflect upside down over the x-axis, both of the signs change from the original. When we are trying to flip it backward and we're putting the negative only next to the x, then only the x term changes sign. All right, so again, let's do it on the next one. If I want to flip this upside down in B, I'm putting a negative on the whole function. Actually, you know what? I'm going to do it underneath here. Negative times negative 1/2 x plus 7. So that would expand to positive 1/2x minus 7. When I substitute just the x, then this would be negative 1/2 bracket negative x plus 7. So then that simplifies to 1/2x positive, right? Both of them are positive because two negatives make a positive, and the plus 7 is unchanged. So hopefully you can kind of see the pattern here. When we are flipping upside down or making the y negative, we essentially distribute a negative across all the terms. So here this would be negative x squared minus 8. Here this would be bracket negative x all squared plus 8. Now here I have a negative inside the bracket, and I have a squared outside of the bracket. Anything squared is going to end up being a positive number, right? Negative times negative is positive. Positive times positive is positive. So I can actually even simplify this further to just say x squared plus 8. Does that make sense? Let's check. If this is a parabola shifted up 8, then my graph looks something like this, where the vertex is up 8, but it's a smiley face parabola. Now, when I substitute negative x for x, what I'm doing is I'm flipping it backward. Well, if I flip it backward and it's still on the y-axis, then it's actually going to look the same. So it does make sense here that a reflection over the y-axis is going to end up looking exactly like the original one because it's symmetric. Right, the parabola is centered out across the middle, so if I turn it around, it's still going to look the same. All right, let's take a look at the next one. Putting a negative on the outside here, I get negative x plus 1 squared. Now I could distribute this into a trinomial and distribute the negative, but I don't really have to. That's pretty simple thing to see. This is going to give me a upside down parabola because it's a squared. And because of the +1 in here, I know that it's going to be moved to the right. Nope, move to the left 1, right? Because we always do the opposite sign for the x. If I were to just substitute the x though, so let's do it this way. We're going to have negative x +1 all squared. Now, we could leave it like this. This would be correct. However, typically when we go to graph some things, we want the coefficient on the x to be +1. So what I'm going to do is I'm going to put these big brackets around it. I'm going to leave the squared on the outside. And on the inside, I'm going to factor out the negative. So I'm going to have negative. That gives me a positive x, -1. So all I've done is I rewrote it in a way that has a +1 coefficient on the x. And then you can notice something else. You could stop here. That would also be correct. But let's take a look. I have a negative here, and I'm going to eventually square it. And based on what we learned here, when you square a negative, you're going to end up with a positive anyway. So this could simplify further to x -1 squared. And this would be the completely simplified and factored form for a reflection backwards. All of them are correct, so don't stress. If you can get here, that's still good. If you can get here, that is better. It'll just make life easier when we go to graph these things. All right, next one. Reflection upside down means I'm changing the sign on all the terms. So negative x -6 + 3. And these brackets here, you can take or leave. It doesn't matter. There's no coefficient in the front here, so there's nothing to distribute. So you can leave them there or you can take them out. It doesn't matter. When I go to do the negative x, though, again, I can simplify it in a couple different ways. I can say negative x -6 + 3. This is correct. You could also say, okay, I see a negative in front of that x, so let us factor it. Negative x +6 + 3. And the reason that we simplify and make sure that there's a coefficient of 1 in front of the x is because when we go to graph this way is a lot easier to see what's happening than this way. Here I can see a negative. I know there's a reflection. I see the +6. I know there's a shift to the left by 6 and up 3. Harder to see it here. So if I were to say, can you rewrite the function with a reflection, both of these are going to be correct. I'm not going to dock marks if you don't simplify. That would be silly. These are both correct. However, this is better. Okay, last two. I'm going to do these ones a little bit quicker now. So now I have negative x + 2 all cubed -8. Here are two terms. I have changed the sign for a y reflection over the x-axis. So we're going upside down. And then here, negative x + 2 all cubed +8. Here's my simplification. Negative x -2 with a cube +8. Now, what happens when I cube a negative number? Negative number times negative number times negative number. These two make it positive. I end up with a negative number. So that means this is negative x -2 all cubed +8. And that would be my simplified version. Again, this is fine. This is better. All right, lots of people ask me about this one in class, so I'm going to do this one and show a lot of work. For the flip over the x-axis, so when I go to do this upside down, I'm adding a negative on the outside to x over x + 3. Typically, when I have a fraction and I have a negative on the outside, I like to keep the negative with the top number. So this would be negative 2x over x plus 3. I do not put a negative in the top and the bottom because negative over negative is positive and they essentially cancel each other out. I don't want them to cancel each other out. I have one term, it happens to be a fraction, so I add one negative. And usually the rule is keep the negative with the numerator. When I go to do this with a reflection in the y-axis, so when I want it to go backwards, I have to replace x with negative x. Here, there are more than one x, so I have to do it more than one time. So this is going to be 2 times negative x divided by negative x plus 3. Let's simplify a little bit. This is negative 2x, negative. I'm going to factor negative out of that bottom there because I want x to have a coefficient of positive 1. There we go. Now here, one term in the top, one term in the bottom. They're both negative. So this actually simplifies to 2x over x minus 3. Again, all of these are correct. This is better.